How and why do our bodies sweat is a question you may have. We have sweat glands embedded in our skin located all over the body. Each sweat gland is controlled by a system within our body called the sympathetic nervous system. A brain signal is produced that activates the sympathetic nervous system to initiate the sweat gland to secrete sweat. For the most part, the water-based fluid produced by these glands is to regulate the temperature of our bodies. But have you ever noticed that whenever you get nervous, your hands or feet begin to feel sweaty? This is related to an emotion, and we call this a psychological signal. To measure this signal, a small voltage can be applied across two parts of the skin, and the skin resistance can be acquired. The reciprocal of this measurement, called skin conductance, is how we quantify this psychological signal. A skin conductance signal can be broken down to two parts: skin conductance level, also called the tonic component, and skin conductance response, sometimes referred to as the phasic component. The skin conductance level is a slow changing signal. It doesn't tell us too much about your emotion, but more about your physical baseline or your everyday value of sweat on your hands. The phasic component, however, is a edgy, fast changing signal. It increases quickly to a peak, then slowly decays over time. So as soon as an emotion is felt, the brain fires a signal. It is a very sharp impulse with a fast decay rate. The impulse starts the sweat glands and the sweat begins to release. This is what's observed in the phasic component. Sometimes we see an overlapping in the phasic component's decays. This is due to multiple brain signals happening within a short time.
From a control system perspective, we consider the skin conductance study of Feige et al. This model includes time invariant coefficients theta naught and theta 1 as time constants, and defines two state variables with x1 being the underlying psychological and emotional state, and x2 the stimulated electrodermal activity. To observe all this, there are a few free softwares available. The first one, called CBX EDA, is an algorithm that uses methods of Bayesian statistics, convex optimization, and sparsity. It was specifically made for examining data such as skin conductance. The algorithm can be easily implemented in MATLAB or Octave software. The example shown here is with MATLAB. You can see the output of this algorithm gives us the brain signal, the tonic and phasic component derived from skin conductance. A second software that can be used is called EDA Explorer. Different methods of identifying overlap SCRs and separating artifacts have been proposed by experts depending on the application and nature of the studies. Early on, some were relying mostly on visual inspection or choose to apply filtering techniques with heuristic thresholds. Recently, to develop a more automatic and empirically evaluated method of identification, Taylor et al. Used machine learning and expert verification to create a publicly available web-based tool for skin conductance peaks detection.
We cannot physically measure emotion, but we can measure skin conductance, and we know these two are highly related. That is why skin conductance is used with many devices that tell you about your emotion. For example, in neuromarketing, it is a field of marketing where physiological signals are recorded to study a person's response to an ad or a movie. By knowing this, one would know if the product or movie is keeping a customer interested or not. Also, another application where skin conductance can be seen popularly used is within health science department, more precisely with wearable devices for condition monitoring. Such an example is the device called Embrace by Empatica, which was fully commercialized, recently approved by FDA, and designed to detect convulsive seizures for people suffering with epilepsy.